Assalamualaikum and good day everyone. Okay, so for this week, we will enter the new chapter. Okay, this week we already entered new chapter, and this chapter is about Fourier series. Okay, Fourier series chapter. Alright, so maybe this chapter is new for you. Maybe some of you will. This is the first time that you heard about Fourier series. Okay, so basically, okay, before we go deep into these topics, I will list down first the what we call the other topics that lies in this chapter. So the first topic that we will cover in this video is about what is a periodic function. Okay, after that we will proceed to the even and odd function. And under even and odd function, of course lah, they have a properties, okay, basic properties. And the third one is Fourier series itself. Okay, and the last topic is about half range series. Okay, so they have 4 topics that we cover in this chapter. So in this video, I will start with the first 2 topics first. Okay, periodic function and also even odd function. Okay, I will use my pen. Alright, so what's mean by periodic function? Okay, actually this is just a definition. Okay, it's just as a definition for you before we go to the Fourier series topic itself. So what's mean by periodic function? Okay, it's a function ft is defined on the interval negative LL. So negative LL means numbers lah. Okay, for example, negative 1, 1, negative 2, 2. Okay, it's a periodic function. Okay, with the period of t equal to 2L if ft plus t equal to ft, whereas t cannot be equal to 0. Okay, so this is the definition of a periodic function. So a function ft defined on the negative LL interval. Okay, this is the interval. So negative LL is a number actually. Okay, for example, negative 1, 1. Negative 2, 2. Okay, must be is equal lah. This one is 1, here also must be 1. Okay, so it's a periodic function with a period of t equal to L. So t here is represent period, time. Okay, t is equal to L if ft plus ft plus capital T is equal to ft, whereas t cannot be equal to 0. Okay, so maybe you feel what is this? Okay, what is this? Okay, so yeah, we just accept it first. Just accept this meaning, because for now it's not they have nothing for us to do with this definition. Okay, we will use this definition later on in the Fourier series. Okay, so yeah, that's it for this one. Okay, now I will go to even and odd function. Okay, so this one is I think is more important for you to know. Okay, to differentiate between odd and even function. This one you just leave it. I mean, you just get the concept. For the periodic function, you just get the concept first. Later we will use it in the Fourier series topics. Okay, alright. So now we go to the even and odd function. Okay, so basically class, so we have we have many functions. Okay, but in terms of odd and even, we have 2 lah. Okay, we have odd and even function. Same goes like we have a numbers, right? We have even numbers and also odd numbers, is it? Okay, so now for function itself, they also have 2 odd and even, and they have 2 ways. Okay, they have 2 approach to determine or to classify whether that function is odd or even. Okay, they have 2 approach. Okay, the first approach is by using equation. Okay, I just equation lah. Okay, equation. And And the second approach is by using graphical. Okay, so you need to sketch a graph lah for the graphical. Okay, so you need to know both method. Okay, because sometimes question asks you to use equation. Sometimes the question asks you to use graphical. So you need to do, or you need to know for both lah, for both approach. Okay, so I give you, okay, I show you first for the equation. Ft is even if, okay, this one for equation if f negative t is equal to ft, okay, this is even, and then ft is odd if, okay, you see the difference f negative t equal to negative ft. Okay class, I repeat, the first one, ft is even if your f negative t equal to ft. So, okay, we will start with negative t inside here, but then it's equal to ft, okay, positive. Now, ft is odd if f negative t is equal to negative ft. So, you can see the difference between odd and even. If even, you have, your answer will be in positive, and even, odd, your answer will be in negative. Okay, so that one is equation. Okay, I just wrote down first the what we call the criteria to make it the equation is odd or even. Later on, I will show you how to solve it lah. Yeah, how to determine it. Okay, and for graph, okay, if the graph of even function, it will be symmetrical on, okay, symmetrical about y-axis, okay, pada part CY on y-axis, and for odd it will be symmetrical about the origin. Origin, okay class, origin means on the 0, 0. Okay, origin, kosong, kosong. Okay, it's not x-axis, it's on origin. For even is y-axis. Okay, what's mean? Okay, so now what's mean by symmetrical about y-axis? Okay, for example, you have a graph. Okay, this is this is the y-axis, right? This is x, this is y. So symmetrical on y-axis means it's when you, okay, we just imagine that we have a piece of paper. Okay, we know that it's symmetrical when, okay, when we flip this paper at this line, it will be symmetry, is it? It will be symmetry. The sizes, the length will be equal for both sides, right? So it means it's symmetrical on y-axis. If you hold like this, it will be symmetrical on x-axis. Okay, class? But now, okay, we have y-axis and we have the origin. Origin is not x-axis, okay? Origin is origin. So let's say this is origin. So maybe it's somewhere here. Maybe it can be somewhere here. It will be somewhere here. But it's not this one. Okay, this one is x-axis. Okay, alright class. So means that if symmetrical on y-axis, okay, I will give you example something like this lah. For example, you have a graph or you have a line y equal to x square. And when you flip this graph, imagine that you flip this one, it will be this line and this line will be attached, right? So the area will be equal, right? So means that this is symmetrical on y-axis. Okay, means that this one, this graph or this line, this function is symmetrical on y-axis. Okay, how about origin? Okay, origin may be something like this. For example, you have y equal to x cubed. Okay, let's say this is your function. So when you flip, okay, imagine that you flip on y-axis. Okay, imagine you flip on y-axis. This line should be here, right? Is it? Okay, this line should be here if you flip on y-axis, and this line should be somewhere here. But it doesn't exist like that. Dia bukan macam tu. Okay, where's my eraser? Okay, it's not occur like that. So what you can see that this one will be attached to this one. So if you flip on the origin, it will be this point will be attached to this point. Okay, so It's symmetrical on origin actually. It's symmetrical on origin. Therefore, this one, this is the odd function. Okay, this is the odd function. Okay, class, so you need to know two approach. First one is by using equation, the second one by using graph. So you need to know each of it. Okay, so later on, later in the next video, I will give you example on how we want to identify whether the function is odd or even. Okay, by using equation and also by using graph. Actually, by using graph, I already show you here. Okay, a little bit how to determine whether the function is odd or even by using graph. Okay, but I will go to details. I will give you more example on the next video. Right, class?